Good everyone, my name is Graphics. Today we want to draw the orthographic view of this isometric block. Now we are going to create a table here, right? In that table we are going to draw the three views, which is the plan, the front elevation and the end view. But now we are drawing looking at this side, the arrow is facing here, looking at this direction as shown in the diagram at the top right corner of the screen. So we want to draw, when you look at this direction, what are you going to see? So let's see what we are going to see. Now, if I should project this in this direction, this way, and I project all the total height and the total length, then the total height again here. So I'm having these four lines. So it meaning that I'm going to join each of those lines as this from this to this point, front line. When we wanted to start our diagram, we first of all draw out a crate, like a complete figure in which we carved out this information. Now the same crate we are going to draw out when we want to draw an orthographic projection. If you have not get in contact with that video, you can click on this link here to take you to the isometric. I will constructed the isometric view of this figure here. Now we move forward. Then I draw this out this way. Now I have carved out the entire shape. This is the entire height. If you measure from here to here is equals to from here to here, right? And from here to here is equals to from here to here. Now if you look at this thickness here, it is 12. I will just project it out from this point here. That means I need this point, and I come here also. I also need this point. So those two lines, I am going to what? Ticking them. So if I come here, I will tick it from here to here, and also ticking these two lines from here to here. And look at this. This is the thickness here. Now the next thing is this curve. We are going to construct this curve. So what I will just do to save our time is that this end here, I'm going to project it to touch here, and also this end here, I'm going to project it and touch here also, right? And that is what we have. So it means that the curve that I'm going to draw will move from here, because from here to here is thickened. So I'm going to thicken that part there. I'll thicken from here to here. So the rest thing is I'm going to draw a curve, because this is a curve, from this point to touch here, and from this point to touch here, and that's what I'm going to use my French curve for. So if I use my French curve, I'll just target from this point to this point here. You can see that. I'll just target from here to here, and I'm going to target from here to here. So this is what we have here. So this is what we're going to see when you're looking at it from that aspect there. So I'll take in from here to here. I'm going to take in from here to here. And I'll also take in from here to here. That again. So this is what you see. That means you see this curve here. Let me say it's point A, and this is A. And you see this here, which is B, and it's also what B. So you're seeing that side looking in from this side, right? And that is the front elevation. So what you do is you're going to draw your four cardinal points at this part here. You draw it this way. I have this, and I also have this. This is what you are asked to if you are told to draw in orthographic projection, right? So I will measure this, then to this side and to this side. That is where I'm going to draw the vertical line this way and also this way. Also from the center, I'll measure 5 up and 5 down, like this. You can use 10 if you want to, and I'm going to do this way, in this manner, and here too, in this manner. So since we are told to draw it in orthographic projection, and we are assuming it is first angle projection, so you draw your elevation here, this you draw it here. So the entire length here from the diagram is given to be 102. So you measure 102 on your meter rule, or you just place it here. This is 100 and this is 102, somewhere around here, right? So 102 will be stopping here. So I can easily take in it from here straight down to this point, 102. And the height from here to here is given as what? As 12, right? So I'll measure the 12 up. I'll measure the 12 up. This is 10, 11, 12. And I'm going to take in it from this part to this part. To this part here. Right? Now, in orthographic projection, your curve is your normal circle, not in elliptical shape. So we said from here to here is given as what? 32, right? So I'll measure 32 from that point because the entire height is 44. So that means 44 plus 12 is 32. So I'll measure 32 from here. So if I start from 1, this is 10, this is 20, this is 30, and this is 32 here. Right? Then 32 here. Then I'll close it up. I'm going to close it up here. Now I want to draw the arc. Now since the radius is 32, this is what we are going to do. You pick your compass and you measure 32 on your meter rule this way. From here, this is 32, or better still, I use this to this point here. You can see what I'm doing? And I'll place it at this edge here. I'm going to mark 32 and this 32 here too, right? And I'll place it here. I'll strike an arc and I'll place it here also. I'll also strike another arc, right? Now with the same radius, I'll place it at that point where they intersect, and I'm going to join from here to here. So we'll call this, since we're making this to become in this shape, we'll call it a fillet when you are dealing with AutoCAD. I'll come here also. I will do the same thing here and here. This at this point, strike an arc. Come here also, strike another arc, right? So where they meet at this point, I'll do the same thing this way. So in doing that, I'll just cover up that place. So this is how you draw it in your AutoCAD projection. You don't have to start constructing and so on and so forth. Now, the next thing I'm going to do is, this is our point A, and this is our point B. Now the next thing under the elevation will be the plan, right? And what I'll simply do here is I'll project this downward this way, and I'll project this downward this way. So let's see, looking at it from the plan, what are we going to have? This is what we have. So if I project this up like this, 4 cardinal points here, these 4 edges. I'll project them up, and these two. You can see that. So what I'm going to do is to join the 4 points together. Let me start from this, right? From this point here. I'll join from here to here. You can see that. And I'll also join from here to here. You can see that. And let me bring this back a little bit. And I'll move this in this direction. Then connect it up. What you see now, I joined those 4 points together, which is this, and this, all the 4 edges looking from the top. Now, if I'm looking at this curve, which is this curve here, this curve from the top, look at what will happen. If I project it up from this end here to be around this point, if I project this up too from this end here to be around here. So looking from the top, this is what you'll be seeing. From here to here, you'll be thickened. From here to here also, you'll be thickened. Right? And from here to here too, will be thickened. Then from here to here too, will be thickened. And from this point to this point too, will be thickened. So this is what you'll be seeing. You'll be seeing this point. We'll say this is A and this is B. So looking from the top, you'll be seeing C and you'll be seeing D. So this is C. All this space here is C, which is all this space. And all this space you are seeing here is D, which is all this space here. So this is the plan, looking from the top, right? So if I do that, means that I am going to measure from here to here is given as 64, right? So I'll just stick in from this point to this point to be 64, right? And also the thickness, which is this thickness here, which is given as 12. You can just easily measure the 12. From here to here is 12 too. You can use your meter rule or you just measure 12. So I'm going to cover up this place, right? Then the entire length is 64. So I can easily measure 64 on my meter rule. You measure 64 on your meter rule, right? And you place it at this point. You mark here. So it means that I am going to connect this point here. So I'm going to cover here too. So I'm going to cover here too. You can see that. So this is C and this is D. CD, CD. Now I will draw this inclined line here. Either I use my 45-degree set square or I just connect this center and this edge here. So I can just draw it this way. You can see that. And I'll project all this to this point. So if I project this point to touch here, project this to this point to touch here, right? Now what are we going to see when we're looking at it from the end view? The end view is always at the side of the front elevation, right? So let's project this and see what we are going to get. So when we project it, let's see. Now if I project that point there to this direction, this to come out here, and all the 4 edges first of all come on out, and then here too. So that's what will come in here now. So project this to this point. Now, if I connect this end here, this to this point here, and all the four ends, I want to connect them together, just like I did in the plan and the front elevation. Just like I did in the plan and the front elevation. So what I will do is, if I project all this edge out here, from here to touch here, and also this edge too, from here, let me say from this edge here to touch here too, right? It means that, and this one too here, from here somewhere around here. Let's start from this top here. If I bring it down, what I'm just doing here is just explaining to you what you're going to see. No one will ask you to do this. It's just for you to understand the basic concept of it. So from here to here is joined to this point. So if I join it, this will come from here and touch here. This also will come from this ending, touch the ending, because from here to here is here, and which is from here to here, and from here to here is from here to here, right? So that is what we have there. And from the top here, it is a curve, but you see it as a straight line since you are drawing in orthographic projection. So I'll just from here, I'm going to cover this point here, and I'm going to cover this point here. So this is what you are going to be having. This is what you will be having here. You can see. So this is, let's call it E, and this is E. This side you're seeing here is F, and that is F. That's what you'll be seeing looking at from this end here. So if I place it at this place, if I project all this inclined, this point at the inclined line upward, you see what I'm going to see. I'll project this to here, I'll project this to here. Now I'll close them up. So this is the last thing you will do. You just close them up. Close them up. So that is the E, and this is the F. So we successfully drawn out the orthographic views that you see. No one will actually ask you to do what I did here, but I'm only doing all these things here to give you a better explanation that the orthographic projection is an extension of the isometric views or the oblique views. So if you have found this video helpful, please don't forget to click on the subscribe button.